welcome back to your maths learning with me this week. I'm hoping you really enjoyed creating your fraction walls yesterday. This is going to be a really helpful, useful tool for you to use throughout this week. So make sure you've got it nearby. If you haven't got it nearby, then there will be one on Class Story that you can still download and still have access to. So let's get started with our learning today then. Okay, so here we go. Let's have a look. So we're going to do a quick rewind. Oh, I've just given you the answers. We're going to have a quick rewind. We're going to have a quick rewind. We are going to think about these three words. So we've got fraction, we've got numerator, and we've got denominator. So explain it, glasses on. Can you explain to me what those three words mean with your knowledge of fractions? Okay, we did do these yesterday, so hopefully they will be fresh in your brains. So can you remember any of the STEM sentences or questions that we might have used to help you remember these? Once you've written those three down, you can come on back and we'll get started with our learning for today. Brilliant. So if you are back with me, it means that you have thought about your three magic fraction words. Okay, so the first one is, what actually is a fraction? Now, our STEM sentence that we used yesterday, it is a part of a whole. Okay, it is a part of a whole, a little action there. The part of a whole. Okay, so all of our fractions are less than one because we see one as our whole. Okay, so if you ever see a fraction, it just means that it's less than one, it's smaller than one, just to help create that picture in your head. It is part of a whole, and we see that whole as one. Okay, so the numerator then, what is the numerator and what is the denominator? Very similar words, ater, so they've got some sort of relationship. So numerator, I'm hoping you remembered, is that top number, and denominator is that bottom number. Okay, top number, bottom number of a fraction. The numerator then, in fact, let's start with the denominator. The denominator is that bottom number, and what does it tell me? It tells me how many equal parts make up my whole. How many equal parts make up my whole. Then you've got your numerator on the top. Now, this is a really important number because I know how many parts make up my whole, but this top number tells me how many of them do I have. Okay, so how many equal parts make up my whole? How many of them do I have? And I've just put that little bit of questions, those questions there for you to refer to in your wake up activity. So let's use it now. So now we are confident with fraction, numerator, denominator. Let's use it. So using your knowledge then of this denominator, how many equal parts make up your whole? Numerator, how many do you have? I'd like you to simply write me A, B, C, D, and E in your books, and I would like you to write me the fraction. Okay, so how many equal parts make up your whole? How many of them do you have? So how many of them are coloured is what we're going to say in this question. How many of them are shaded? So how many are yellow? How many are purple? Sort of a browny colour, a grey, and a blue. Okay, so all I want you to simply do is write me those 5 fractions. Once you've written those, an extra little prove it challenge, could you find them on your fraction wall? And using that knowledge from yesterday, so that word should be red, are any of them equivalent? So remember, let's rewind that word before we get started. It is equivalent if it has or shows the same amount or the same value. So if you look at these fractions on your fraction wall, do any of them give you that same amount of that whole, that bar that you've split up into those parts? Okay. So what are the fractions shown? Are any of them equivalent using your fraction wall? Once you've had a go at that, come on back. Brilliant. So hopefully if you're back with me now, it means that you have had a little go at this. So let's get our fractions for each of those diagrams down here. So remember, I have my line in the middle. My bottom number, how many equal parts does this shape have? So 1, 2, 3. It has 4 equal parts. And how many of them do I have? 1, 2, 3 of them are yellow. So my fraction for that one, you should have 3 quarters, because remember, whenever there is a 4 as your denominator, we use the language quarters. So 3 quarters. This one here, little trick. This is what I do all the time to make sure I can count them properly. Dot them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 equal parts. And how many of them do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 of them. Same with this one. So 9/12 for B. Well done if you got that. 8. 8. How many of them do I have? 5. So what's that fraction there? 5/8. Well done if you got that one. We have 8 again, but can you see slightly different way to split your whole, but it's still split into 8. 1, 2, 3, 4, 5, 6 of them I have. So there I've got 6 8s. And this one here, oh, big one here, and I can count these in my 4s because it's going to be quicker. 4, 8, 12, 16. How many of those have I got that are blue? 3, 6, 9, 12. 12 16ths. So what have we got here then? 3/4. B was 9/12. C was 5/8. D was 6/8. And E was 12/16. Okay, fantastic. Well done to you if you got those right. Right, let's have a little look then at the extra little challenge if you managed to have a look at it. If you didn't get onto it, don't worry, you can look at it with me now. Okay, so I want you to grab your fraction walls and make sure you've got it in front of you. Again, if you haven't got one, just have a look at that one on class story that I've put on there for you. Here is my fraction wall. Just get my blue tack. Pop it on here. You can see that. Move it a little bit more close. Move it a little bit closer. Okay. So even if you can't quite see mine, you can still see what I'm doing and have a go with your fraction walls at home. Okay. Make mine a little bit straighter. Yeah. Okay. So you can see here my fraction wall, and I've started to simply shade in these fractions. So my first one was 3/4, so I've shaded 3 of them. Okay, the next one, 9/12, so I'm going to my 12ths all the way down the bottom here, and I've shaded 9 of them. So you can see, let me just get my silver pen. So a bit of a darker line, so you can see where we're looking. Okay, there we go, there's my new one. That's better. Okay, that one's gone all the way up to there. Next one, I've got 5 8s, so there's my 8s. I've got 5 of them, which is this one here. And then the next one, I've got 6 of them, so that's an extra one. Then I have got 12/16, which I don't actually have 16ths on my fraction, so we're going to leave that one for now. So if they're equivalent, remind me, what does that mean? That they take up the same amount of space of that whole. It's the same amount, the same value. So what I'm going to simply do is, using my ruler, I'm going to go from my 3/4 and I'm going to put my ruler down to see if any of them are showing me the same amount of that whole. So you can see there's my 3/4. I'm going to go down. Now 5/8 is here, so is that the same amount? Is that an equivalent amount? No, but look here, your 6/8 is showing exactly the same amount as my 3/4. So on my board, what I can then show you, using my fraction wall, 3/4 is equivalent, so equal to 6/8. Can you see any more on your fraction wall that might be equivalent? I can see here that my line is lining up also with the 12th. So how many 12ths did we have? We had 9 12ths. So I can say that it is also equal to 9 12ths. So you can see how this is a really, really, really useful tool at seeing and visualizing your equivalent fractions. Okay, so we've got 3/4 is equal to 6/8, which is also equal to 9 12ths. Okay, so what I'm going to do is I'm just going to put the last one, 12/16 there. Okay, all I want you to do, you could add an extra row onto your 12/16, or you might be starting to see a little pattern, or you may already know the pattern. So my question then, 12/16, is that equivalent or not? I'm just going to leave that one with you. So well done if you got those three were equivalent, and this one possibly we're not 100% sure yet. So let's get on then with today's learning. Okay, so today we're going to be identifying, naming and writing. We're not necessarily going to be just writing them today. We're going to be focusing on using our fraction walls to actually show them. Okay, new learning is practice because we've just started this learning. And why? So that we're able to find and show a range of equivalent fractions. So let's have a look at this one first then. Okay, so the first thing I want you to do with this question is explain it. So simply looking at this question, so Rena, Richard, Louise and Emma have designed their own flags. I just simply want you to look at those flags. What is the same? What is different about each of those flags? The quite obvious one that is different is they are different colours. But does that matter to our maths learning? At the minute, no. So think about mathematically what is the same and what is different. Once you've had a little look at them, your main question is, convince me, which one is the odd one out and why? Okay, so one of those flags is the odd one out and why? Once you've done that, could you try and prove that the one that you have made, they've chosen, sorry, is the odd one out? Could you show it using either the fraction numbers? You might want to use your fraction wall, or you might want to do another drawing to show that they are different. Okay, so what's the same and what's the difference about each flag? Which one is the odd one out and why is that one the odd one out? And is there another way that you could prove or record this information to show that you are correct? Once you've had a go at that, come on back. Okay, so hopefully you've had a little go at that. You've had a little look at them. So I'm just going to talk you through what I did when I looked at this question, and then hopefully we will get to an answer at the end. Okay. Okay, so the first thing that I noticed straight away is I'm going to look at Richard's. Okay, so I'm going to look at each of them and just going to think how many parts do I have? How many of them have been coloured? So here straight away I notice that they've all got different parts, denominators. So the first thing I would have done, and I did do, was actually think about the denominators. So that one has 2 equal parts. That one has 4 equal parts. That one has 3 equal parts. And that one has 8 equal parts, okay? So I'm not seeing anything similar yet, okay? Then I'm going to think about the numerators. I've got 1 that's shaded there. I've got 2 on that one. I've got 2. So that might be a similarity because they've got the same parts shaded. That could be a similarity. And this one I've got 4, okay? But remember, I'm only looking for one that is the odd one out. So actually, the fact that they've got the same numerators, does that help me? Because then those two would be 2 odd ones out. Okay, I want odd 1 out. It would be an odd 2 out, of course. Okay, so the next thing I'm going to look at then. Now, the first thing that I notice now that I'm looking more at the colours and at the designs of the flags is actually if I swap those two from the right-hand side to the left-hand side, something magical starts to happen. What can you now see? So if I make those white, what can you now see that looks very similar to one of the other flags? What can you now see? I'm seeing that this one, let me just change my colour. I'm now seeing that this one and this one now has the exact same amount shaded. So even though there are more parts on this one, more smaller parts, they are still shading, I can see half of that shape. Can you see it's been split down the middle there, and this left-hand side has been shaded. That one has the same split down the middle there, and this has been shaded. So I think those two are very, very similar. Now I just need to think, is there another one that can compare that can be similar to these two? So they're shading half. Actually, I know my fraction knowledge straight away there, because I know that this fraction, although it looks slightly different, it is still half of the shape, because that fraction is a half. Half of that shape is red. Okay, even though it's been split horizontally rather than vertically, it's still half of that shape. It's still the same whole, and it's still half of it. So there's a half. That's showing me a half. And that is now showing me a half. So which one would we say is my odd one out? I'm going to go with this one. Now, I'm going to try and prove why. Okay, so like I did with this one, you might have wanted to draw this one again and shade in, almost just have a move of that green part that's shaded there, because it doesn't matter which parts I shade, as long as there's still two of them shaded. It might be able to show me if that one was now white, and I'm going to think about the half of the shape now. So that one is now moved down there, so I can now see, but I'm going to just do another line just to make sure. Let me make sure I get a straight line. I'm going to chop half of that shape, so it's around about there, but look, can you see that that is actually more than half? Whereas these are showing me a half exactly. So I know that 2/3 is more than a half. So that one is my odd one out. Okay, and I've proven it here by showing you what half looks like on that shape, and this one is more than half. So these ones show me half exactly, whereas 2/3 shows me more than half. So that's why I'm going to go that one is the odd one out. So which one is the odd one out and why? I'm going to go 2/3 is the odd one out, because 4/8, 2 quarters and a half are all equivalent fractions. They all show me a half of the shape. So well done to you if you got that right. If you didn't get it, I'm hoping that my convince me and my prove it have now very clearly shown you why they are different. Fabulous. So we're going to continue with this focus of finding equivalent fractions. So the same amount, the fractions that give you the same amount of that whole. Okay, so they will have different denominators, they'll have different numerators, but they're still going to give you the same amount of that whole. So here you can see I've already shown you a half. And as we've just learned from the previous discover, how many quarters is equivalent to 1/2? Now I've used exactly the same hole here, because remember, you have to have those same holes so that you can see whether they use the same amount of that space up. So how many quarters do you think makes up the same amount as that hole? I'm just going to get a colour here. So I'm going to go for 1. Now that one isn't quite the same amount, so I'm going to go for another one. And now you can see that they are showing the same amount of that fraction. So that is red all the way up to there, and now that is shaded in the same amount. So how many quarters do I need to get the same amount as a half? I know I need 2 quarters. Okay, so the same question for this one here then. How many? So hopefully you've got your fraction wall at home, but if you also want to draw these in your books, that's absolutely fine. Completely up to you. I would suggest using a plain piece of paper though, as your squares might confuse you a little bit in your math book. So maybe plain paper is the better idea for this one. But remember, the same hole is the best way. Next one then, so again, the same hole, but this time I've split it into 8 equal parts, and remember they must be equal. So how many of these 8 parts will give me the equivalent amount of my 1/2 and my 2 quarters? We've just done this in our practice, and I remember that it is 4. Okay, so let's get my little cubes and let's prove it. Let's double check our answers. So there's 1, still not the same amount, it's a lot less. 2, oh, I can see here though that my 2 of my 8s is actually equivalent to 1 of my quarters. Can you see that? But I don't want 1 quarter, I need 2 quarters. So I'm going to have to fill in another 1 and another 1. There we go. Can you see? Again, it's taking up the exact same space of that hole. It is the same amount. So correct, it is 4/8. Now this one here, I'm just playing around with this because I'm starting to notice a pattern. If I have 2 parts, I shade one of them. If I had 4 parts, I shade 2 of them. What's the relationship that you're starting to see with these numbers? Thinking about half, they are equivalent to a half. So I've got 2 parts, I shade one of them. I've got 4 parts, I shade 2 of them. And if I've got 8 parts, I shade 4 of them. I'm starting to see a pattern here, and I'm going to see if my pattern is correct. I'm hoping you're starting to see a pattern at home too. So I'm going to go for 10. My denominator is now 10. What do you think, using your knowledge of these numbers and using your knowledge of halves, how many parts do you think is going to give me equivalent to a half? I'm seeing a pattern here and here. So I'm going to go with, I want you to explore that first before I give you the answer. So what I'd like you to do is to have a little go at drawing lots of different diagrams. So keeping that same whole, but splitting it into different denominators to see if you can find an equivalent to a half. There may be some relationships that you might start to notice between these numbers. You may even start to see a relationship between the denominator and whether you can show a half. Okay, so I just want you to explore just for the next sort of, maybe have 5-10 minutes on this, just to see how many different ways you can represent a half. Once you start getting confident with this, you can go as wacky and as crazy as possible. Okay, so about 10 minutes I want you to spend just exploring a half to find the equivalent fractions to a half, and then come on back when you've had a go, and we will see if you were correct with my 10 as my denominator, my 10 equal parts, how many of them would I need? So don't forget to do that one first. So I'm hoping that you have found lots and lots and lots of different ways of creating a half, and you've already started to notice a pattern. So the pattern that I noticed, I wonder if you noticed it too, is when you are showing an equivalent fraction to a half, your denominator and your numerator have a pattern. Your numerator is half of your denominator. So half of 2 is 1, half of 4 is 2, half of 8 is 4. So if I'm following this pattern, half of 10 should give me 5 pence. So let's see if I am correct. Let's prove it. Let's either use your fraction rules, or let's use my diagram that I've actually created here. I'm going to go a different colour. So 1 part, 2 tenths, 3 tenths, 4 tenths, and 5 tenths. Exactly half of that whole has now been shaded. So 5 tenths is also equivalent to 1/2. So we started to see a pattern now between our halves. So well done to you. But you can see how you can split your wholes into lots of different parts and still find those equivalent fractions. Again, this is a really helpful skill to show that. Okay. Well done. So some great exploring there. So what we're going to do now is we're going to apply it into a little bit of a questiony situation. Okay, so here you can see that the question 1 and question A and B, I've shown you some diagrams of some fractions. Okay, so this one is 1/3. They've already given you that. It just simply wants you to see how many sixths now is equivalent to 1/3. So you can see they're taking up that same space, but what they've done there, they split it into 6 equal parts now rather than 3. Okay. And then this one here, they've given you 6/18ths. But what is the equivalent fraction that they have shown over here? What have they actually done? How many parts have they put it into now? Now, you may start to see some relationships between your fraction numbers. Okay, that will give you a little bit of a head start on tomorrow's learning. So if you can start to notice some patterns while you're doing your diagrams today, that is brilliant. Maybe make a note of any patterns so that you're explaining it down here. Are you beginning to see any patterns? So what I'd like you to do is to complete the 2 that are in the question, but then use that same diagram to see if you could find any other equivalent fractions. So using those diagrams there, any other equivalent fractions that you could then also add to this long line of them here. So once you've had a go at those two, and you found use your diagram to make any more equivalent fractions, you can then come on back and we will get on with today's learning. Brilliant. So hopefully you've had a go at that now. If not, pause me and have a little go before I give you the answers. So let's have a little look then. Let's get my pen. So here you can see this is showing me one part of the three parts that make up my whole. So it's 1/3. So here what they've done is they've simply split those thirds each into two parts now. So you can see each of those thirds has now become two equal parts. So 6 now makes my whole. How many of them will give me the same amount? 2. Okay. Now, what I would have done straight away there is I can see that if I now split them equally there, so mine's not as equal as it should be because it's hard on a computer, because remember all of your parts need to be equal. I can now see that each of those thirds that I started with is now 4 equal parts. So how many parts make up my whole now I've added that? It's 12. And how many of them make up my equal parts? 4. Okay, so you can see how if you start with a fraction and then you can split it down further, you can start to see those equivalent fractions. So well done to you if you got that one. You could have taken this even further. So I'm sure you may have got lots and lots and lots more, but you might also start to see a bit of a pattern emerging there. Okay, so this one here, slightly different because I've started with more parts that make up my whole, and then I've become less parts that make up my whole. So what's actually happened here? So instead of splitting that original one into smaller parts, I've now joined those parts together to make larger parts, which means now my denominator is less. So it was 18, but I've then put these back together. So I've now got 1, 2, 3, 4, 5, 6 parts. I've merged 3 of those parts back together to make one part, which is now giving me 6. And how many of them give me the same amount? 2. So I know that 2/6 is equal to 6/18. Now I'm going to steal what they did on this one here, and I'm just going to simply chop this. Ooh, again, yours will be much better. It's harder to use a ruler on here. I've now just simply split that all the way down the middle. What have I got now that would still give me that same amount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, another 12s. 4. Oh, I'm starting to see a bit of a pattern here. Look at this. So 1/3 is equal to 2/6, but so is 6/18 is also equal to 2/6, and they're both also equal to 4/12. So what could you probably say about 6/18 and 1/3? I think we could also say that they are all equivalent fractions. They will all show you the same amount of that whole. Brilliant. So there we found 1, 2, 3, 4 equivalent fractions. So well done to you if you got that and if you started to see that pattern. Okay, fantastic. So I'm hoping you may start to be seeing the relationship between those numbers there. So if you have got that and you're starting to see the relationship between these numerators and the denominators, just write it down because we will be doing this tomorrow. Okay, today we're just focusing on making sure that we're really, really confident with what that equivalent fraction actually looks like. And we'll be doing lots of drawing of them today. Tomorrow we're going to be moving on to something else. So let's have a look then. Your independent activities today then. On your class story, you will see that I have posted this sheet, this PDF. So feel free, if you can print it off at home, then you can print it off because it will be a little bit easier. But don't worry if you can't, you can just simply draw these fractions in your books. Okay, so we're going to be looking for those equivalent fractions. So remember those fractions that take up the same amount of the whole. So here you can see that you've got lots of shapes and lots of lots of shapes that have all been split into different parts. Okay, and what I would like you to do is to simply shade your, find out what equivalent fractions are by shading the different amounts, the amounts of parts to make the same amount. Okay, so I just want you to, it's just a bit of an explore it today, just so you can start to see, once you've done it, can you write the fraction underneath that you have created to show whether it is equivalent or whether it's not equivalent. Okay, so it's just a way for you to explore today lots of different ways and lots of different equivalent fractions for 1/2, 1/3, and 1/4. Can't wait to see all of the exploring you do. Remember, if you start to notice any patterns or any problems, then feel free to write them down and send them to your teachers on portfolio. We love when you explore your own learning. So I will see you all back again tomorrow to develop this a little bit further. See you all soon. Goodbye.